Right, so here we are at the University of Bath, checking out the RepRap machine. It's the 3D printer that prints itself, reprap.org. Well, about money. Here we are with Adrian Bowyer.
Hello.
In the lab. Tell us about RepRap, Adrian.
Right, okay, well let's look at it. Here it is. This is the latest RepRap machine. It's the second one we designed. We call this one Mendel. The first one was called Darwin. They're all going to be called after a famous biologist because it's a machine that reproduces itself. It doesn't reproduce itself completely, but what it can do is to make a significant fraction of its own parts. This machine can make all of these whitey silvery coloured parts that you can see distributed around all over it. And if you count them up and you ignore nuts and bolts, then that's about half the machine. If you include nuts and bolts, the entire machine is made from nuts and bolts. Though as you can see, that's not true.
So it's about 50% self-replicating at the moment.
It's about 50% self-replicating.
How much is that the old machine over there?
That's about the same proportion, actually. We haven't increased the proportion because we weren't too fussed with getting that too high. We were more concerned with the second one, getting it easier to put together, because human ease of assembly is actually the thing that's on the critical inhibition to getting the technology taken out. But this is the first machine. This is Darwin. As you can see, it's bigger than the second machine, but it's also smaller. It's a bit TARDIS-like. It's bigger on the outside and smaller on the inside.
Yeah, I hear that Mendel can print bigger things.
This can make bigger things than that one can, even though that one was much bigger physically. This machine can make things anywhere on this blue base here. This blue material is painter's masking tape, incidentally, which is what we build on.
Right.
The way it works is we have a filament of plastic. Here it is.
There's this plant base.
This is a plant-based plastic, yes. This one's polylactic acid. You can make that from starch. And it's chemically fairly straightforward process to make, if you want to make your own, with one tricky step. And the tricky step is you've got to get it very, very dry at one point. I don't just mean leave it drying out in a warm place. I mean less than 10 parts per million H2O. And
so that requires, I guess, quite a lot of heat.
It doesn't need a lot of heat. It needs a very dry atmosphere in which to do it. But we think we can probably do it by blowing air over dry calcium chloride to dry the air out, and then passing that dried air over the powder. We haven't tried that yet, though. It should work. Anyway, if I turn the machine round, you can see there's a little stub of the plastic sticking out there. That's the last bit, and the last bit we used in the machine. We normally have a big roll of this stuff, and it goes down through there. And this motor dries that down, and then if we look underneath, we can just about see, just here, that's the extrude nozzle of the machine. That's a bit of brass bolt with a hole drilled down the middle of it. The plastic melts inside there because it's got an electric heater around it, and is squirted out of a small hole in the bottom of the machine. And the machine then, down without trapping its own wire, the machine then moves this head backwards and forwards this way, and this backwards and forwards this way, and scribbles a pattern on this base here. This whole assembly then moves up on these two screw threads here by a fraction of a millimetre, and it scribbles the next layer and scribbles the next layer, and after about half an hour or so you've made one of these bits, or one of these bits, or indeed anything else you should want. That process is entirely automatic. All you need is a computer model of the three-dimensional shape that you want to make. Computer models like that are fairly easy to create these days, and there's free software for doing it.
What are some of the names of the free software you can use?
There's a package called Blender, and there's another one called Art of Illusion. Both of those work absolutely fine. There's a whole load of them listed on the RepRap website. If you don't want to design your own object, there's also a growing library of objects called Thingiverse, which is founded and run by one of the guys on the project, Zach Smith. There, people can upload designs for objects to be printed, and anybody can then go and download them and print them out. And in recent weeks, for example, there was a great flurry of Christmas decorations which appeared, unsurprisingly. So you can print your own Christmas decorations.
Have you got some printed bits
yes,
and bobs?
Let's have a look at some bits.
Yeah.
Oh, there's a very simple part. It's a gear wheel. It's a gear wheel that we were working on. We thought we'd use that in the design for that machine, but in fact we changed the design of that to this now. This is a longer gear. That's the gear that's actually in the machine. What else have we got? Oh, here's an object that you can't make by any other means. This was built in layers this way, and in fact it's two things, one inside the other, such that when it was finished you can't then take it apart.
Right, I get the whistle's a bit like that as well.
Yeah, the whistle has got
whistle.
a little P inside it. There's a drinking glass, again made of polylactic acid. Polylactic acid isn't the only material that we use. It is also possible to use ABS, which is the Lego brick plastic. This is an object made in ABS.
Oh, that blue one.
Yes, and yep.
Are these? Do you finish them off somehow? Cause
no, this is as it came out of the machine. In fact.
Well, I guess you can have, because you can still see the lines in there, can't you?
Yes, that's true. That's a very early piece. We made that years ago on the first machine, and it's a bit crude compared to what we can do now, which is rather better quality.
This one as well?
No, that was made in a commercial machine, just for comparison, as was that. Not all of these things are made in RepRap machines. The majority were. Occasionally things go horribly wrong, and we end up with one of those. This is a very simple object that I made the other day. It's just, I needed a switch in an electric wire. There's a hole there for the wire. It goes in, comes out, and there's a switch on the top. I designed that and made it in about half an hour. It would have taken me longer than that to go to a shop and buy one. This is yet another plastic. This is HDPE, which is the milk bottle plastic. We're experimenting with that as well, because one of the things we'd like to do is to design a shredder that the machine can make, and then instead of feeding that long length of plastic into the machine, we'd feed plastic granules into the machine. And of course, if you've got a shredder that the machine makes, you can shred your own milk bottles, feed them into the machine, and recycle your milk bottles entirely locally. No trucks running up and down the motorway full of empty milk bottles.
Yeah.
And of course, and we actually use...
How far down the line of things like that?
We haven't designed the shredder yet. As soon as we've designed the shredder and the granule extruder, both of which we've had ideas about, we haven't had time to finish, it'll be there. Or someone else might do it, because it's an open source project. Anybody's free to do that.
So RepRap itself is open source along with the software that you power it with?
RepRap, the software, the documentation, everything is licensed under the GPL and is free.
Great.
Free as in beer and free as in money. As in freedom. This, as I say, is the milk bottle plastic. That was done with another filament of milk bottle plastic. We had to make it into a filament first, like the filament I showed you just now. And that's yet another material that we were thinking of using. We used it to make these child sandals, which are quite fun. And of course, the nice thing about that is that when your child's feet grow, as they so inconveniently do, all you do is shred the sandals, throw in another milk bottle, scale the design by 1.1, and you've got a bigger pair of sandals. So not only do you recycle the milk bottles to make the sandals in the first place, you recycle the sandals to make more sandals and bigger ones with an extra milk bottle.
Great, and am I right in thinking that that Mendel, this new machine, will also soon be able to do circuit boards?
Yes, there are two possible ways that we might go. This is a very experimental circuit board that we made in the machine, but this technology is not really there ready for release yet. This is actually the equivalent of this little device on the machine, which you can see here is made in a conventional circuit board. That's actually the end stop, which tells it when this has got to the end of its travel in that direction. This is an equivalent, and the rather horrible circuit on the back there was put down automatically by the machine. It's rather horrible because it's molten solder that we put into channels that we left in the plastic when the machine built the plastic. And that works, and we could probably make it better quality than that by concentrating on it, and that's one way we might go. Another possibility is illustrated by this rather unimpressive looking object. That's actually a plastic part, the silvery whitey bit made in the machine, and we've deposited in a channel in that some carbon-based material sets that gives us an electrically conducting track, and it's smeared a bit on the sides because, again, this is highly experimental. That's fine. It allows you to do resistors as well as conductors, which is nice, but what it doesn't allow you to do is very high current very low resistance conductors.
Excellent. Well, I'm going to stop now because we're at 10 minutes.